Welcome to Science, to Sleep By. Tonight, as the stars drift silently over the dark horizon, we turn our gaze toward a quiet traveler, a visitor from another solar system known as 3I Atlas. For months, astronomers watched it glide through the black velvet of space, expecting to see a bright, sweeping tail stretching behind it, a trail of dust and vapor glowing in the sun's distant warmth. But what they found instead was silence. New images have revealed something remarkable, and perhaps even more mysterious about this interstellar wanderer. 3I Atlas does not have a tail. No shining arc of light, no trace of escaping gas, no radiant plume marking its path. It moves through the cosmic dark like a polished stone across the deep ocean. Calm, unbothered, perfectly still. Tonight, we'll explore what that means scientifically, and perhaps even spiritually. We'll drift through the story of how astronomers discovered this, what it tells us about the nature of interstellar objects, and how a simple absence, the missing tail, can whisper something profound about how our universe works. So take a breath. Let your thoughts slow. Let the science of the stars carry you gently toward rest, as we unfold the quiet truth of a cosmic traveler that chose stillness over spectacle. The night sky has always held a certain rhythm, one that humankind has listened to for thousands of years. The slow rotation of the earth, the soft glimmer of distant stars, the quiet arcs of celestial travelers making their way through the heavens. For many of us, that rhythm is comforting, like the slow pulse of the universe breathing in the dark. It is in this deep quiet that we begin our journey tonight. Not with noise, not with spectacle, but with the calm expectancy that something unseen might soon reveal itself. The story of 3I Atlas begins not in the roar of discovery, but in the hush before it, in the soft anticipation of astronomers who had their telescopes trained on a dim, wandering light between the stars. When the object known as 3I Atlas was first detected, it came with whispers of excitement. It was not native to our solar system. That much was quickly understood. Its speed, its trajectory, its path through the night sky, all pointed to something extraordinary. This was a visitor from beyond. Just like the enigmatic one Oumuamua before it, 3I Atlas arrived from the interstellar deep, slipping quietly past the outer planets, moving on a path that would never circle back. For astronomers, moments like these are gifts, glimpses into the unknown, opportunities to study material that was born around another star, perhaps another sun, somewhere unimaginably far away. But what made 3I Atlas so intriguing in those first moments was not just its origin. It was the possibility of a show. Many early observations hinted that it might be a comet, not an asteroid. A comet means drama. It means sunlight catching frozen gases, transforming them into glowing tails of vapor and dust. It means motion, change, a bright thread of light pulled across the sky. Telescopes were turned toward it with eager precision. Astronomers from Hawaii to Arizona, from Chile to orbiting observatories above the atmosphere, all watched and waited for the signature shimmer that would prove their theory true. And yet, night after night, the data returned with an unexpected stillness. Images came in without the faintest blur behind the nucleus. No sign of sublimation, no jets, no expanding halo of icy debris. 3I Atlas remained serene, just a pinpoint of light, steady and unadorned. In an era when discovery often means spectacle, this quietness seemed almost defiant. The universe, it seemed, had chosen to whisper rather than to sing. The calm before revelation is often where the deepest truths hide. In that stillness, astronomers began to look closer. They recalibrated instruments, compared exposures, studied the wavelength profiles of reflected sunlight. What they saw was fascinating. The object was not behaving like any active comet at all. Its brightness did not fluctuate the way a body-shedding material would. Its spectral signature showed no trace of the usual gases like cyanide, carbon dioxide, or water vapor. It was, by all measurable accounts, inert. But in the early days of study, scientists held their breath. After all, the cosmos has a way of surprising even its most seasoned observers. Comets can wake suddenly, their tails bursting into life as they approach the sun, Some remain dormant until the last possible moment, erupting only when solar radiation reaches a threshold. So researchers waited. They tracked 3I Atlas as it glided closer toward its perihelion, the point in its orbit nearest to the Sun. If ever there was a time for a tale to bloom, it would be then. And yet, even in that moment of maximum warmth, nothing stirred. The object passed the Sun in utter composure, its surface unresponsive, its body still silent. This quietness was not disappointment, it was revelation. Because in astronomy, absence is as meaningful as presence. When something fails to behave as expected, it speaks volumes about its nature. In those tailless images, scientists began to see a different story unfolding. Perhaps this interstellar traveler was not a comet at all. Perhaps it was more solid, more ancient, more scarred by the radiation of countless cosmic years. Perhaps it had once been active, millions of years ago, in the light of a different star, and now drifted as a fossil of another system. Its surface sealed by eons of exposure to interstellar dust and cosmic rays. The calm before the cosmic revelation was filled not with the roar of discovery, but with the deep hum of curiosity. Researchers ran models, simulating how the Sun's heat might interact with various compositions. They imagined a body made not of ice and dust, but of metals and silicates, something denser, something that no longer responded to warmth. Some speculated that 3I Atlas might have once been part of a shattered planetesimal, flung free from its birth system during the violent formation of worlds. Others suggested it could be an icy relic, long ago covered by a dark carbon crust, insulating it from the Sun's touch. Whatever the case, the discovery, or rather, the lack of one, was not a failure of expectation, but an invitation to look deeper. Astronomers turned to polarization data, infrared imaging, and radar observations to tease out more clues. The stillness of 3I Atlas became a kind of cosmic meditation, forcing scientists to sit with the unknown, to let their assumptions dissolve, and to let the data speak in its own quiet way. Beyond the technical details, there was something poetic about this moment. In a universe often defined by explosive phenomena, supernova, quasars, violent collisions, here was a traveler defined by stillness. The same stillness that fills the space between stars. The same stillness that settles in the human mind when we stare up at the night sky and realize how vast it all is. For astronomers sitting in control rooms late at night, sipping coffee beneath glowing screens, that stillness carried a strange peace. It was as if 3I Atlas had come not to dazzle, but to remind us that not every story written in the stars burns brightly. Some stories glide quietly, leaving no trail at all. And in that quiet, there was beauty. A reminder that the universe does not always perform for us. Sometimes, it simply is. A motion without adornment. A light without flare. A mystery without announcement. The calm before revelation was not empty. It was full of questions, of data waiting to be understood, of the slow turning of human wonder meeting the quiet truth of the cosmos. Before the new images arrived, before the telescopes resolved the truth in such still clarity, the name 3I Atlas carried with it a quiet thrill. For astronomers, the mere discovery of a new interstellar object was like opening a cosmic letter addressed from another world. It meant that something from beyond our sun's domain had wandered into our skies, carrying within it the frozen chemistry of another star system, a system that may have formed millions or billions of years ago. And so, naturally, the first thought that bloomed in the scientific mind was that this new visitor might be a comet. Because comets are storytellers. They speak of origins, of water, of the ancient materials that once built worlds. When 3I Atlas was first detected, the excitement was not just about the object itself, but about the story it might tell of how other solar systems are born. The early data hinted at just that. Its brightness fluctuated slightly, its orbit appeared hyperbolic, meaning it was not bound to the sun. It came from the distant reaches of interstellar space, moving too fast to ever return. Those qualities, the speed, the angle of approach, the faint shimmer of light that seemed to pulse as it tumbled, all suggested the behavior of a comet. Scientists began to compare it to 2I Borisov, the interstellar comet discovered just a few years earlier, which had arrived with a glowing, unmistakable tail and a coma of gas expanding around it like a delicate halo. Perhaps, they thought, 3I Atlas would be the same, a second interstellar comet, proof that such objects might be common wanderers between the stars. Telescopes across the world were trained to watch. The Pan-STARRS survey, the same system that had first detected it, refined its measurements. Amateur astronomers joined in, submitting early images that showed a faint blur, not enough to be certain, but enough to hope. Astronomers imagined the frozen nucleus, rich in ices and organic molecules, beginning to awaken as sunlight struck its surface. The sun, after all, is a great sculptor of comets. It warms them, releases their hidden gases, and carves luminous tails that stretch millions of miles into space. To think of such a process happening to an object that had come from another star system filled researchers with awe. They were watching an interstellar story unfold. Perhaps the first time sunlight from our sun had ever touched its ancient crust. In lectures and conferences, the early conversations were filled with cautious optimism. The naming of the object 3I Atlas carried meaning, the 3I indicating it was the third interstellar object ever confirmed. An atlas honoring the asteroid terrestrial impact last alert system that spotted it. Even the name evokes something mythic. Atlas, the titan who carried the heavens on his shoulders, now lending his name to a traveler that carried the secrets of another sky. Scientists and storytellers alike leaned into the poetry of it. They imagined dust trails sparkling through the void, faint tails drifting under solar radiation, echoes of a distant creation. But science, as it often does, lives in the tension between expectation and observation. For a time, those expectations defined the way we thought about 3I Atlas. We believed it would behave like other comets because it seemed easier that way. The human mind, even the scientific one, seeks patterns, familiarity, and continuity. When faced with something alien, we frame it in what we already understand. In that way, 3I Atlas became, for a while, a mirror reflecting not its own nature, but our assumptions about how things from the cosmos should behave. Researchers began running models. They projected how much water ice could sublimate under the heat of the sun, what kind of dust particle sizes might scatter light, how quickly a faint coma might develop. They compared its orbital distance to Borisov's, wondering if the tail would appear at a similar point in its approach. Every telescope image was watched closely for signs of motion blur, spectral signatures, or any hint of volatile activity. To the untrained eye, the data seemed calm, but to those waiting behind computer screens and observatories, each pixel of light was a heartbeat. Each data set a potential breakthrough. The story was building, and all it needed was confirmation. The belief in 3I Atlas's cometary nature was not without reason. After all, the odds favored it. Comets are more likely to be ejected from planetary systems than solid asteroids are, because they form in the outer, icy regions where gravitational interactions can easily sling them into interstellar space. Many scientists argued that what we were seeing was likely an interstellar comet that had yet to fully awaken. Perhaps it was still too far from the sun for its surface to react. Maybe its icy components were buried deep beneath the crust that would soon fracture and release vapor. Some even proposed that it might show delayed activity, a tail forming suddenly as it neared perihelion, when the solar heat reached its peak. The public too was fascinated. News articles began to circulate about a new interstellar comet visiting the solar system. Animations showed a bright, glowing tail sweeping past the sun. For a brief moment, 3I Atlas lived in our collective imagination as another cosmic performer, a traveler bearing light from another star. Even those who didn't follow astronomy could feel the sense of wonder that we were not alone in the galactic sea, that material from distant systems sometimes wandered close enough to see. It was a reminder that the space around us is not empty, but alive with movement, with exchange, with unseen travelers drifting between suns. And so, astronomers prepared to document what they believed would be the awakening of another interstellar comet. Instruments were synchronized, observation schedules arranged, and radio telescopes aligned to capture any chemical emissions that might emerge. Every night became a vigil. There is something almost spiritual about such anticipation, waiting not for sound, but for silence to break, waiting for light to shift, waiting for nature to whisper its next line in the cosmic dialogue. The belief that 3i Atlas would show a tale was as much about hope as it was about science. In the calm darkness of observatories, researchers watched with patience as weeks turned to months, and through that long watch, the data continued to arrive, slow and silent, each image another note in the cosmic melody. They believed they were waiting for a transformation, a moment when sunlight would turn an ancient traveler into a spectacle of light and motion. What they didn't yet realize was that the absence of that transformation, the stillness itself, would become the revelation. The belief in what 3i Atlas would become was built on everything we knew about comets. But soon, the universe would show us that knowledge, no matter how vast, is sometimes just the beginning of understanding. There are moments in science when silence turns to revelation, not through words, but through light captured across the darkness. The story of 3i Atlas reached such a moment when the first high-resolution images began to flow in from telescopes spread across the Earth and orbiting above it. For months, astronomers had gazed patiently at the faint dot moving slowly across the sky, tracking it night after night as it slipped through constellations. They had waited for change, for the faint haze of dust, for the telltale signature of gas escaping into the void. Instead, the new images arrived with the kind of serene finality, carrying within their pixels the truth that had eluded speculation. They showed a traveler untouched by the sun's warmth, a body gliding through space without a single trace of a tail the moment those images came through. Many astronomers felt a curious mix of awe and quiet disbelief. The data had been processed carefully, layered across exposures, checked against background stars to rule out artifacts or distortions. There was no mistake. The long-expected glow of dust and gas simply wasn't there. The telescopes that had captured comets in bloom, that had watched Borisov's brilliant arc only years earlier, now saw nothing but a compact, well-defined point of light. It wasn't just faint. It was precise. The edges were clean, the light steady. 3i Atlas was a solitary traveler, bare of any trailing mist. From the powerful lens of the Hubble Space Telescope to the wide-field eyes of Pan-STARRS and the deep optical reach of the European Southern Observatory, the images all agreed. Each telescope, viewing from different vantage points and wavelengths, returned the same result. 3i Atlas moved unadorned through the cosmic night. In the language of data, the universe had spoken clearly. The object was not radiating dust, not emitting jets, not forming any halo of activity. Even the infrared observations, which could have revealed faint thermal emissions from sublimating ices, showed none. It was as if the sun itself could not wake this wanderer from its long interstellar sleep. For scientists, those images were more than just photographs. They were windows into the truth of composition. A comet's tail is born when frozen gases within its core sublimate, turning directly from solid ice to vapor under solar radiation. This vapor carries along dust and particles, reflecting sunlight and forming the glowing arc we associate with comets. The absence of that phenomenon in 3i Atlas meant that its surface was sealed, its volatiles trapped or gone entirely. The images suggested a body that was dark and inert, perhaps covered in a crust of carbonized compounds that prevented solar heat from reaching its interior. Such a surface, hardened by countless years drifting between stars, would make it nearly impervious to the sun's energy. As more images arrived, the story deepened. Using spectrographic analysis, researchers studied how sunlight reflected off the object's surface, breaking the light into its component wavelengths to look for clues about its material makeup. The results came back flat: no spectral lines indicating water vapor, no emission spikes from carbon compounds or cyanide, nothing resembling an active comet. The reflected light was neutral, slightly reddish, typical of rocky asteroids or dormant cometary nuclei. It was as though the object had shed its youth long ago, its icy vitality replaced by the hard silence of age. Teams around the world began to re-examine their assumptions. At first, some wondered if the tail could simply be too faint to detect. Cometary tails can vary greatly in brightness, and an interstellar object might not behave like those from our own system. So they pushed their instruments to the limits, stacking images, stretching exposure times, and enhancing contrast to hunt for even the weakest trace of diffusion around the nucleus. Yet every attempt returned the same calm certainty. 3I Atlas was as sharp as a star. Its light did not spread, it did not fade, it did not scatter. It moved cleanly against the background sky, like a stone skipping across the ocean's surface. In the data rooms of observatories, the reaction was not disappointment but quiet wonder. To see something so foreign, so unchanged by the sun's proximity, was to witness a piece of the galaxy itself passing by, a fragment of another world's history, untouched and unaltered. The new images were not merely confirming the absence of a tail, they were rewriting the object's identity. What had been labeled a comet began to resemble an asteroid, though even that term felt incomplete. It was a traveler without a category, a bridge between definitions, something both familiar and alien. NASA's teams, along with independent astronomers, began to circulate the new findings. Papers and preprints appeared online within days, discussing the possible explanations for this tail-less nature. Some proposed that 3I Atlas was once an active comet that had long since exhausted its volatile materials. Others suggested it might be a fragment of a larger interstellar body, chipped away in some ancient collision before being ejected into deep space. The fact that it reflected sunlight without visible emission hinted at a surface that was dense, compact, and likely composed of rock and metal rather than ice. In the quiet language of science, every pixel of those images spoke of endurance. The object had likely spent millions, perhaps billions, of years traveling between stars, bombarded by cosmic rays, its surface baked into stability. In that time, it had lost whatever delicate ices once lay beneath its crust, leaving behind only the relic of its form, a fossil drifting through eternity. When the new images revealed this truth, the object ceased to be just a curiosity. It became a messenger from time itself. It told of processes that happened beyond our reach, of solar systems long extinct, of the slow weathering that occurs not from wind or water, but from the endless silence of space. Even among those who had spent their lives studying celestial objects, the clarity of the images inspired reflection. There was something deeply human in the act of expecting a tail, a symbol of light, of spectacle, only to find a deeper beauty in simplicity. The stillness of 3I Atlas carried its own kind of radiance. It was as though the universe had painted this lesson in starlight. Not every traveler must blaze to be seen. The absence of a tail was not emptiness. It was truth. And in that truth lay a portrait of resilience, of survival, of the quiet dignity of matter that endures beyond worlds and epochs. The images, when released to the public, stirred fascination. People who had followed the earlier excitement about a possible new comet now looked at the stark points of light and felt a new kind of wonder. Here was something not performing, not transforming yet profoundly real. It was the cosmos in its purest form, distant, silent, mysterious, and infinitely patient. For astronomers, those new images marked a turning point. They were no longer waiting for a tail to appear. They were studying something that had resisted even the sun's touch. A body from beyond the stars that had traveled untouched through the dark, and in its quiet passage, reminded humanity how small and temporary our expectations are compared to the vast, unhurried truth of the universe. To understand why 3I Atlas moves through space without a tail, one must first understand the anatomy of a comet, what it means for a celestial body to come alive under sunlight. A comet, in its simplest form, is a frozen relic from the earliest moments of planetary formation. It is built from the same ingredients that once swirled in the protoplanetary disks around young stars: water ice, carbon dioxide, ammonia, methane, and dust. In the cold outer reaches of a solar system, far beyond the warmth of its star, these materials remain locked in silence, forming small, solid worlds no larger than mountains or cities. But when such a body drifts inward, into the light, the transformation begins. The sun's heat penetrates the crust, vaporizing ice into gas, releasing pressure, and carrying with it streams of dust that catch the sunlight. That glowing veil becomes the tail, the shimmering signature that marks a comet's passage across the heavens. The tail of a comet is not a single structure, but a dance of forces. One tail, composed of dust, curves gently under the influence of the sun's gravity, while another, the I-don't tail, stretches in a straight line away from the sun, carried by the solar wind. These tails can extend for millions of miles, so vast that they dwarf the planets they pass. They are fragile and fleeting, ephemeral displays born of the constant exchange between heat and cold, matter and energy. For a comet, the tail is both life and decay. A brief moment of brilliance before returning to the deep freeze of the outer dark. 3I Atlas was expected to follow the same pattern. When it was first spotted entering the inner regions of our solar system, its trajectory and behavior suggested it could be a comet awakened from interstellar sleep. But when the telescopes found no tail, no coma, no evidence of outgassing, astronomers had to turn inward to the structure itself. The anatomy of this traveler defied expectation. It did not respond to solar heat. It did not sublimate. The energy of sunlight, which normally triggers cascades of chemical reactions on an icy surface, seemed to vanish upon contact. The object absorbed light, reflected some, but produced nothing in return. It was as if the body had no breath, no motion beneath its crust, no whisper of the volatile life that defines a comet. To study this anomaly, scientists began reconstructing the physical nature of 3I Atlas. They considered its albedo the measure of how much sunlight it reflects and found it to be dark, suggesting a surface coated in carbon-rich material, much like the outer layers of asteroids or extinct comets that have long since spent their ices. Over time, the bombardment of cosmic rays in interstellar space can harden and seal the outer crust of such a body, forming what researchers call a devolatilized shell. It is a natural armor, a layer of organic residue that prevents the sun's warmth from reaching the deeper ices within. If 3I Atlas possessed such a crust, it would explain the silence of its approach. The object could contain frozen material deep inside, but none of it could escape. The traveler had become inert, its anatomy preserved in a timeless state of dormancy. The surface of such an interstellar body would not be smooth or reflective. It would be rough, perhaps jagged, covered in fine dust that has been fused by radiation over countless millennia. The outermost microns of material would be chemically altered, a kind of cosmic varnish, darkened by exposure to high-energy particles as it wandered between stars. Beneath that hardened layer might lie the ancient ice of its birth, but it would remain trapped, hidden, unreachable. The anatomy of 3I Atlas was no longer the anatomy of a living comet, but that of a fossilized one. It was a monument to stillness, a frozen relic from another solar nursery, carrying within it the memory of its origins. The tail that never formed was not a failure of physics, but a revelation of composition. The sun, though powerful, could not coax a reaction from this alien body because the chemistry no longer allowed it. Unlike the fresh, unweathered comets of our own solar system, which still bear volatile ices near their surfaces, an interstellar object like 3I Atlas has traveled through cosmic radiation for millions of years. Each collision with high-energy particles strips away its outer layers, leaving behind a compact and resistant crust. In essence, the object is both comet and asteroid, a hybrid of stone and ice that has lost its capacity to breathe. The anatomy of this traveler is therefore not just about what it is made of, but about what time has done to it. Some astronomers modeled its structure using thermal simulations, calculating how much heat would penetrate under varying assumptions of composition. The results were striking. Even when exposed to the sun at close range, the simulated surface temperature of such an object remained too low to trigger sublimation if the outer layer was sufficiently thick. A few centimeters of carbonized dust would be enough to lock in the cold. That meant the anatomy of 3I Atlas was shaped not just by its birth, but by its long exile between the stars. It had been sealed by time itself. In the deeper layers of the object, layers that no telescope can see, lie the remnants of its creation. Scientists imagine it formed in the icy outskirts of a distant solar system, where temperatures were too low for rock alone to dominate. There, grains of ice and dust collected, merging slowly under gravity, building up into a body perhaps a few hundred meters wide. Then, through the chaos of planetary formation, gravitational tides or collisions could have flung it out, casting it into interstellar space. For millions of years, it drifted through clouds of gas, through radiation, through emptiness, until it found its way into our solar system. What we see today is the surface of that journey, the anatomy of endurance written across every atom of its crust. The absence of a tail also reshapes how we think about the boundary between comets and asteroids. Traditionally, we draw that line based on activity. A comet breathes. An asteroid does not. But interstellar visitors like 3I Atlas challenge that simplicity. They show that cosmic bodies can evolve beyond those categories, that the anatomy of a traveler is fluid, dependent on history, exposure, and chance. A comet may live, then sleep, then fossilize, becoming indistinguishable from rock. In this way, 3I Atlas is not a contradiction, it is a continuum. A living example of how celestial objects transform over time. Shaped by forces too slow for human eyes to see, astronomers, in their careful analyses, often speak of such objects in numbers and measurements, diameter, reflectivity, orbital inclination, but beneath those figures lies a quiet poetry. The anatomy of a tailless traveler is a record of endurance against the radiation of the cosmos, a testament to the persistence of matter across distances we can hardly imagine. It has no tail because it no longer needs one. Its silence is the mark of its survival. Its surface, though dark and cold, carries within it the chemical echoes of a different star's creation. When scientists examine its light, they are, in a sense, dissecting the anatomy of another world, peeling back the layers of time to glimpse the shared materials of existence that link all solar systems together. Through the absence of motion, through the stillness of its form, 3I Atlas reveals itself as a traveler beyond life and decay, a fragment of a forgotten cosmos, still carrying the structure of its birth. Its anatomy is a reminder that in the language of the universe, silence can hold as much meaning as brightness. And a tale that never forms can teach us more than one that blazes briefly across the night sky. The stillness of 3I Atlas is not emptiness, but an expression of physics working in silence. Behind that quiet exterior lies a story written in energy, motion, and time. A story that reveals how the universe preserves, transforms, and hides its creations. When astronomers looked upon the motionless body of 3I Atlas and saw no tail, no vapor, no cometary breath, they were not witnessing a failure of activity, but the triumph of equilibrium. The object had reached a balance with its environment so perfect that nothing changed. To the naked eye, this looks like stillness, but to the physicist, it is the endpoint of countless interactions that cancel one another out, leaving behind an almost meditative calm. The sun, the central engine of our solar system, is a furnace of radiation. Its energy flows outward in all directions, carried by light and particles known as the solar wind. When a comet approaches, these forces play upon it like an instrument. The light warms the icy surface, causing sublimation, the direct transformation from solid ice into gas, while the solar wind sweeps those gases away, forming a tail. The process is dynamic, noisy, constantly changing. Yet in the case of 3I Atlas, none of this occurred. The sun's heat arrived as usual, but the object remained unmoved. The reason lies in the nature of its surface, its thermal inertia, and the protective chemistry that coats it. Over millions of years, traveling through the void between stars, any exposed cometary material becomes hardened by cosmic radiation. These high-energy particles strike molecules on the surface, breaking them apart and recombining them into long, complex chains of carbon materials known as tholins. Tholins are dark, sticky, and incredibly resistant to heat. They form a shell, only micrometers thick, but dense enough to insulate the layers beneath. When sunlight touches such a surface, much of the energy is absorbed and re-emitted as low-level heat rather than penetrating deeper. In effect, the object becomes its own shield, unable to awaken because it has been sealed by time. 3I Atlas, then, is not inert by chance, but by evolution. Its stillness is the product of eons of exposure to cosmic radiation that gradually erased its sensitivity to light. To test this, scientists use thermal models to simulate what would happen if the object were composed of materials similar to those found in known comets. They calculated the rate of heat conduction from the surface inward, the point at which ice would begin to sublimate, and the amount of gas pressure that would build beneath the crust. The numbers showed that if the crust was only a few centimeters thick and composed of dark carbon compounds, the heat from the sun would not penetrate enough to trigger activity. The layer would simply warm and cool in daily cycles, radiating energy back into space. It was as if the traveler had developed a natural armor against the very forces that once shaped it. The stillness of 3I Atlas also reflects its interstellar journey. Unlike bodies within our solar system, which are constantly influenced by the sun's gravity and radiation, interstellar objects travel through environments almost devoid of such effects. In those vast, cold stretches between stars, temperatures hover near absolute zero. Under such conditions, molecular motion nearly stops, and any volatile material becomes stable. The longer an object remains in that state, the deeper its dormancy becomes. Its atoms settle into equilibrium, its ices contract, and its outer layers densify. By the time it enters another solar system, it has already forgotten how to react. What we call stillness is the deep memory of cold, carried for millions of years. When astronomers examined 3I Atlas through spectroscopy, they found no signs of vapor or chemical emissions, confirming that no sublimation was occurring. Instead, they detected a faint, reddish reflection, the signature of organic compounds similar to those found on asteroids like Bennu or Ryugu. These compounds, created by radiation acting on carbon-based molecules, absorb most wavelengths of light and give the object its muted tone. The same process that preserves 3I Atlas also conceals its interior, making it appear dark and unyielding even as sunlight falls upon it. In the language of physics, this is energy conservation made visible. The energy arriving from the sun is almost perfectly balanced by the energy leaving its surface as infrared radiation. Nothing is wasted, nothing escapes, nothing changes. Some researchers propose that this balance could reveal the object's density and internal composition. If 3I Atlas were porous, sunlight might penetrate more deeply, leading to localized heating and eruptions. But the steady light curve, the way its brightness remained constant as it rotated, suggested a solid, compact body. Its density may be similar to that of rock or metal-rich asteroids, not the fluffy ice dust mixtures typical of comets. That alone would explain its composure. An object this dense would not expand or fracture easily under thermal stress. It would simply turn slowly, reflecting sunlight from one hemisphere to the other, and troubled by the warmth that stirs lesser bodies to life. The stillness also speaks to the boundaries of scientific expectation. When 1I Oumuamua, the first known interstellar visitor, passed through the solar system in 2017, it too defied classification. It showed no tail, no coma, and yet it accelerated slightly, as if pushed by some unseen force. 3I Atlas, by contrast, moved with perfect consistency, obeying every rule of celestial mechanics. Its path was clean, its motion predictable, and its behavior textbook. To some astronomers, this made it even more remarkable. While Oumuamua teased mystery through deviation, 3I Atlas embodied mystery through precision. The physics behind its stillness is not the absence of action, but the total obedience to natural law. To grasp that, one must imagine the equilibrium conditions at play. Every photon of light that strikes 3I Atlas carries energy that could, under the right conditions, cause molecules to vibrate, bonds to break, and gases to escape. But if the material is dark enough, and the heat dissipates quickly enough, those reactions never happen. The surface remains calm, the energy flows in and out without incident, and the entire object remains in steady thermal balance. It is a cosmic version of perfect peace, a state in which forces act but cancel one another, where energy flows but does not disrupt, Astronomers have long understood that such equilibrium states are common in the universe. Stars burn steadily for billions of years by balancing the inward pull of gravity against the outward pressure of radiation. Planets orbit in stable patterns that repeat endlessly, neither falling into their stars nor drifting away. Even galaxies maintain their spiral shapes by balancing rotation and gravity. 3i Atlas, in its small, quiet way, is another expression of this principle, a harmony between heat, cold, matter, and motion. Its stillness is not an accident, but a fundamental property of the universe's tendency toward balance. There is also a chemical dimension to the stillness. The compounds that cover its surface, carbon, nitrogen, oxygen, perhaps traces of iron and silicate, interact weakly with one another under low temperatures. Unlike reactive molecules that transform easily, these compounds form long, inert chains. They are resistant to breakdown, resistant to vaporization, resistant even to impact erosion in the absence of atmosphere. The chemistry of 3i Atlas has aged into immobility. When sunlight touches it, the photons scatter but find no receptive bonds to excite. The molecule does not respond. The structure does not shift. It simply absorbs and releases, again and again, without change. From a human perspective, the stillness of such an object feels like quiet, but in reality, it is the quiet of perfection. Every process within 3i Atlas is operating at its most stable point. The sun warms, the object reflects, the radiation fades, and equilibrium holds. There are no eruptions, no tails, no chaos, only the timeless efficiency of physics expressing itself in silence. It is a portrait of matter at peace with the forces that surround it. In the boundless dark between stars, there is a silence so complete that it becomes almost a presence in itself. It is in that silence that 3i Atlas once drifted, a traveler without destination, moving through the ancient corridors of the galaxy. Every atom on its surface, every scar etched into its body, speaks of distances so vast that they make human imagination tremble. 3i Atlas was not born here. It is not of our sun, nor of any familiar family of planets or comets. It is a messenger from somewhere beyond, a fragment of another solar system, flung outward long ago, carrying the memory of its origin like a sealed letter that only the stars can read. To understand a visitor like this is to understand exile. Somewhere in a distant region of the galaxy, a star once blazed with its own circle of worlds, perhaps surrounded by icy belts and wandering asteroids. In that system's early chaos, collisions between forming planets and cometary bodies were frequent, powerful enough to hurl fragments into the void. Some of those fragments, perhaps 3i Atlas among them, were launched at such speed that they escaped the pull of their home star entirely. Once beyond the reach of gravity, they entered the slow drift of interstellar space, a journey not of years or centuries, but of millions upon millions of years. The distance between stars is so immense that even at tens of kilometers per second, such an object would need eons to cross it. For most of that time, nothing happens. No light, no heat, no collisions. Only a gentle accumulation of cosmic dust and the steady bombardment of invisible radiation. As 3i Atlas traveled, it passed through clouds of interstellar gas, through shockwaves of ancient supernova, through electromagnetic fields stretching for light years. Each encounter changed it in microscopic ways. Its outer layers became chemically altered, its surface roughened by the steady whisper of particles, and its once active core fell into dormancy. It became something between a relic and a fossil, a time capsule adrift in infinity. In this way, it represents not only a scientific curiosity, but a story of endurance. Few things in the universe last so long or travel so far while remaining intact. 3i Atlas is not a visitor in the usual sense of the word. It is a survivor. When it finally entered our solar system, it was the third known interstellar object to do so, following in the faint wake of 1 Oumuamua and 2 I Borisov. Each of these travelers carried its own mysteries, and each one challenged astronomers to redefine what it means to belong to a solar system. For centuries, the study of comets and asteroids was confined to our sun's domain. Everything that moved was presumed to have been born here, influenced by our planets and our light. But interstellar visitors shattered that assumption. They reminded us that space is not a collection of isolated islands, but an ocean, and that sometimes, across its unimaginable distances, something drifts from one shore to another. For the scientists who tracked 3I Atlas, the realization of its interstellar origin was both thrilling and humbling. Its trajectory did not follow the curved path of objects bound by the sun's gravity. Instead, it described a perfect hyperbola, a shape that only belongs to bodies passing through once, never to return. That single mathematical curve told a story of infinite distance. It was proof that this visitor had come from elsewhere, untouched by our star until now. The precision of that path, measured by radio telescopes and optical arrays, painted a picture of a Voyager gliding effortlessly through the inner solar system, unaffected by anything except the faint gravitational tug of the worlds. It passed. To the naked eye, 3I Atlas would have appeared as a dim point of light against the cosmic backdrop, invisible without powerful instruments. But to those who knew what they were looking for, it was more than a speck. It was a symbol of connection between systems that may never otherwise meet. Its lack of a tail, the quiet dignity with which it moved seemed almost poetic, as if the object refused to announce its presence. It slipped between worlds silently, observed only by the patient eyes of machines, and then continued on its way. For humanity, its arrival was a reminder that the galaxy is alive with motion, that the void is not empty, but filled with travelers too rare and ancient to count. Scientists compared its spectral data to models of known materials, searching for clues to its birthplace. The colors of light reflected from its surface hinted at complex organics, molecules that can only form under long exposure to radiation. These compounds told of an origin in a region rich with ice and carbon, perhaps far from the warmth of its native star. In that distant cradle, frozen matter and dust mingled in the cold outskirts of a planetary disk, until an accident of gravity sent one fragment on a path of escape. That fragment, now called 3I Atlas, may have watched the light of its own star recede into darkness before beginning the long drift that would eventually bring it here. There is a peculiar loneliness to that image. A small world cast adrift, wandering through eternity. Yet within that loneliness lies beauty, for in its silence, 3I Atlas carries the unbroken record of time. It has seen the galaxy turn upon itself, seen stars ignite and fade, seen the great arms of the Milky Way sweep slowly across its path. It has been untouched by atmosphere, by erosion, by tectonics, its form preserved like a cosmic fossil. When we look at it through telescopes, we are not seeing something new. We are seeing something old beyond comprehension. Every photon that bounces from its surface carries the signature of age, the faint echo of a history that began before our species existed. As-3 Atlas passed between the orbits of planets. It became a silent envoy from another place, a reminder that our solar system is not the center of all things. The idea that matter can travel from one star to another blurs the boundaries between worlds. It suggests that the universe is connected not just through light and gravity, but through touch, that even the smallest fragments of rock and ice can weave a thread between distant suns. For those who study planetary formation, interstellar visitors like this provide evidence that the building blocks of planets, and perhaps even life itself, are not confined to single systems. They wander, they scatter, and they share their chemistry across the galaxy. 3I Atlas, then, is both a traveler and a messenger, bearing the materials of its birthplace across the void. In the serene light of distant space, its passage is brief, yet the implications linger. Each visitor that enters our solar system expands our understanding of what is possible. Each one reminds us that we are part of a cosmic community, vast, ancient, and interconnected. When scientists look upon 3I Atlas, they are not merely studying a rock. They are reading a fragment of another world story. Its stillness, its tailless body, its precise motion. All of these are clues written in the language of the stars. And though its journey will soon carry it away again, back into the dark between worlds, it leaves behind a question that hums softly through the night sky. how many others are out there, drifting and seen, carrying the whispers of their home stars across the endless sea of space for generations? Humanity has looked to the night sky and imagined comets as harbingers of light and change. They were the messengers of the heavens, radiant wanderers whose luminous tails painted streaks of fire across the dark canvas of space. Every culture that ever looked upward gave them meaning, omens, spirits, signs of destiny. But science, with its patient curiosity, stripped away the superstition and replaced it with understanding. A comet, we learned, was an ancient remnant of the solar system's birth, a frozen mixture of dust, rock, and ice that awakens when touched by sunlight. It was the simplest kind of world, and yet the most dramatic. The moment it approached the sun, it would breathe, it would burn, it would reveal its inner soul in a blaze of vapor and light. For centuries, that image defined what a comet was supposed to be. And then came 3, Atlas, a visitor that quietly refused to play that part. To say that 3I Atlas redefined what a comet can be is to admit that our categories are fragile things. When astronomers first detected it, they expected the same pattern: a brightening coma, a glowing tail, an eruption of activity as it neared the sun. But instead, the object remained still, dark, and unresponsive. Its light curve stayed flat, its spectrum silent, its surface composed. At first, this behavior was puzzling, even disappointing. A comet without a tail seemed to contradict the very definition of the word. If it does not shine, if it does not exhale its icy breath into the void, then what is it? Is it a comet at all? Or something else entirely? A new kind of celestial traveler that does not fit neatly into our familiar boxes? This question struck at the heart of modern astronomy. Labels like comet and asteroid were born in an era when scientists could only see the solar system's inhabitants as points of light. The distinction was simple: comets had tails, asteroids did not. But as our instruments improved, we began to discover objects that blurred the boundaries. Some asteroids released gas under certain conditions, while some comets remained inert even near the sun. The discovery of 3I Atlas, tailless and unwavering, forced astronomers to confront a truth that had been growing quietly for years: that the universe does not honor human definitions. It operates on its own continuum, where every object is unique, and every label is merely a convenience. In that sense, 3I Atlas did not simply defy classification, it expanded it. Its stillness was not absence, but variation. It revealed that interstellar comets, shaped by alien suns and unfamiliar chemistries, might behave in ways that our solar system has never shown us. Perhaps in its native system, the object once had a tail. Perhaps it once erupted and glowed, centuries ago, when its ices were fresh and its surface unscarred. But after drifting through the deep cold between stars, its volatile materials had long since sealed away. The energy that would have once driven its outgassing was trapped beneath hardened crusts, its chemistry transformed by radiation. By the time it reached our sun, it had become something else, something quieter, older, wiser. The astronomers who studied 3I Atlas began to speak of dormant comets and transition objects, those that straddle the boundary between activity and silence. The term interstellar object itself became a broader category, encompassing comets, asteroids, and all the strange hybrids that pass from star to star. What was once a tidy distinction had now become a spectrum. In this new view, comets' tail is not a defining feature, but a temporary phase, a symptom of youth and proximity to heat. Without the sun's warmth, a comet is simply a body of frozen memory, indistinguishable from rock. 3I Atlas reminded us that the absence of activity is not the absence of identity. It is a different kind of being, one that reflects the vast diversity of conditions that exist across the galaxy. To redefine what a comet can be is to expand our sense of cosmic possibility. It invites us to imagine comets that form in exotic systems, under different stars, with compositions unlike anything found here. Some may be rich in ammonia, some in methane, others coated in metallic frost or organic tar. Some may erupt violently when warmed, while others remain still, their chemistry locked in perfect balance. The discovery of 3I Atlas challenges us to look beyond familiar behavior and consider that the universe may craft its wanderers in endless varieties. The word comet becomes less a definition and more a story, one of origin, journey, and transformation. Even the lack of a tail carries meaning. In the glow of traditional comets, the tail is a symbol of impermanence, the visible reminder that time consumes all things. It is the vaporization of the object's very body, the shedding of its material into space. A comet's beauty is the beauty of loss, but 3I Atlas, without a tail, without that bright plume of evaporation, embodies endurance. It is the opposite of the classic image, not a body dissolving into light, but one that resists dissolution entirely. It moves through the same sunlight that melts other comets and remains whole. In this sense, it redefines beauty as persistence, not the flash of activity, but the quiet integrity of survival. The deeper scientists looked, the more philosophical this discovery became. If a comet can exist without a tail, then what else have we mistaken as absolute? The universe has always challenged human certainty, but moments like this make that challenge personal. They remind us that our definitions are shaped by limited experience. We think we know how things behave because we have observed them within our small corner of the cosmos. But when something arrives from beyond, it carries the possibility of the unknown. 3I Atlas is a kind of mirror. It shows us not only what it is, but how narrow our understanding can be. In laboratories and observatories across the world, scientists began revisiting old data. Could other so-called asteroids have been dormant comets? Could our own solar system hold silent travelers that once were bright? The boundary between categories began to dissolve. 3I Atlas became a touchstone in this shift, a reminder that science is not a fixed map, but a living exploration. Each discovery does not close a question, but opens 1,000 more. Its silence also led to practical insights. By studying an object that shows no outgassing, astronomers could isolate the physical effects of solar radiation, pressure, gravity, and thermal emission without interference from vaporized material. It became a natural experiment in celestial mechanics, allowing scientists to refine models of how light itself can influence motion. In that stillness, there was clarity. The absence of a tail did not simplify the story, it deepened it. The public reaction to 3I Atlas mirrored this evolution in understanding. Many had expected another dazzling spectacle, a comet lighting up the night sky, a repeat of the brilliant displays that inspire awe and myth. Instead, they were told of a darkness, a quietness, a comet that would not shine. Yet there is something profoundly moving in that restraint. The universe does not always announce its wonders with light. Sometimes it whispers them through silence. 3I Atlas invited us to find beauty not in what is seen, but in what is unseen. In the quiet geometry of its orbit, in the precision of its movement, in the still endurance of its form. By its very nature, 3I Atlas reminds us that the cosmos is more subtle than we imagine. The universe is not made only of the bright and the dramatic, but also of the dim and the enduring. In redefining what a comet can be, it reminds humanity that discovery often means surrendering certainty. Every new object, every anomaly, every quiet visitor, teaches us that the story of creation is far larger and far more diverse than we have ever dared to believe. And in that knowledge, as we lie beneath the stars and listen to the soft hum of the cosmos, there is a deeper kind of wonder, the kind that does not need light to be seen, only stillness to be understood. There is something hauntingly poetic about an object that crosses the universe without leaving a trace. For all of human history, we have associated movement with evidence: the footprints in the sand, the vapor trail in the sky, the ripples on the surface of the water. Yet 3I Atlas, this silent traveler from another star, offers us an entirely different kind of presence. It moves through our solar system without fanfare, without trail, without the visible breath that marks other comets. Its lack of a tail, its refusal to shine, becomes more than a physical phenomenon. It becomes a symbol, a meditation on what it means to exist quietly, to journey without spectacle, to endure without leaving behind the familiar signs of passage. When astronomers first realized that 3I Atlas had no tail, it was not merely a scientific curiosity. It was a disruption of expectation. They had anticipated activity outgassing, dust clouds, a coma illuminated by sunlight. That is what a comet does when it nears a star. But this traveler, this piece of matter older than our own sun, did none of those things. It was serene and self-contained. The data from telescopes showed an unwavering light curve, no signs of gas or dust escaping, no changing brightness that would suggest a reaction to the sun's heat. It was as though the universe had decided to show us what a comet might be if it could achieve complete self-control. And in that calm, there was something deeply moving, a stillness that defied the violent forces surrounding it. In physical terms, the absence of a tail can be explained through chemistry and physics. 3I Atlas's surface, likely hardened by eons of cosmic radiation, had become coated in complex organic materials, a shell so dark and insulating that it prevented any sublimation of underlying ice. The sun's energy, though vast, was not enough to penetrate that shield. Instead of erupting into motion, the object absorbed and re-emitted energy in perfect balance, maintaining its frozen integrity. But beyond this physical reasoning lies a quiet metaphor that humanity cannot help but feel. The tail of a comet is often seen as its identity, its performance, its song across the heavens. Without one, 3I Atlas appears stripped of that expression. Yet perhaps that is the lesson, that existence does not depend on display. That significance does not always require light. To see 3I Atlas is to be reminded of the quiet travelers in our own world. The things that move unseen, yet shape everything around us. Gravity itself leaves no trail. Time passes without a mark. The earth spins, the air flows, the galaxies rotate, and all of it happens in silence. The universe, at its heart, is not a theater of noise, but a choreography of stillness. 3I Atlas is an embodiment of that truth, a cosmic mirror reflecting the beauty of restraint. In its lack of activity, it shows us that motion need not be loud to be meaningful, that presence can exist without proof, and that sometimes the most profound forces are those that do not draw attention to themselves. Astronomers studying this visitor were not disappointed by its silence. They were captivated by it. Each observation forced them to think differently about the nature of interstellar matter. Could there be billions of such travelers moving unseen through the galaxy, invisible simply because they do not emit light or vapor? Could our solar system itself have been visited countless times by such bodies, their paths recorded only in the gravitational memories of planets and stars? The thought is staggering. 3I Atlas, then, is not just one object, it is the representative of a hidden population, a glimpse into a shadowed dimension of cosmic migration. In that sense, the meaning of a tailless traveler expands beyond the individual. It becomes a symbol of all that passes unnoticed, all that exists beyond the limits of human perception. Our telescopes, for all their power, are still narrow windows. We see only the bright, the active, the illuminated. But the dark spaces between those lights hold secrets that are no less magnificent. 3I Atlas reminds us that invisibility does not mean absence. It invites us to imagine a galaxy filled with silent voyagers, each carrying the residue of another world, each drifting through eternity without announcement. The meaning of a tailless traveler, then, not only scientific, but existential. It challenges us to reconsider what it means to make an impact. Perhaps impact does not require leaving something behind. Perhaps to move through life, or through the cosmos, without disturbance, to pass gently, to remain intact, is its own kind of legacy. 3I Atlas, in its silent flight, shows us that motion itself is enough. The absence of a tail is not the absence of story. It is a story told differently, through calm instead of eruption, through darkness instead of flame, through endurance instead of transformation. In its silence, it carries the voice of the universe itself, speaking softly through the void, reminding us that not all travelers blaze trails of light. Some glide unseen, yet still reshape the way we see the sky. As the final echoes of this celestial story fade into the stillness of night, we are left with the image of a traveler silent, solitary, and infinite. 3i Atlas has crossed our solar system like a shadow between worlds, showing us that the universe's wonders are not always wrapped in light. Its absence of a tail, its refusal to flare or shine, was not a flaw, but a revelation. In that calm, we found meaning. We discovered that stillness itself can speak, that silence can carry truth, and that the cosmos does not need spectacle to inspire awe. Every telescope pointed toward 3i Atlas captured more than data, it captured perspective. It reminded humanity that the most profound discoveries often come not from what burns brightly, but from what endures quietly. A comet without a tail, moving through the sunlight without response, becomes a symbol of resilience, of balance, of timelessness. It tells us that the universe is vast enough to contain every kind of traveler, those who blaze, and those who simply glide. Science, at its heart, is not a pursuit of brightness, but of understanding. 3i Atlas deepened that understanding by inviting us to listen to the cosmos differently. It taught us that absence can be presence, that mystery can live in simplicity, and that even in silence, the universe is speaking. For as long as it continues on its endless journey through the dark, untouched and unchanged, it will carry with it a quiet reminder of our place among the stars. That to exist, to endure, to move without losing oneself, is its own kind of light.